Hi, welcome to my channel Industry 4.0. Today, in this video, I shall explain Industry 4.0 and HVDC technology. You will learn how does the HVDC transmission system work. Also, know the types and benefits of HVDC system. Please like and share the video and subscribe to my channel. So, let's start the video. Introduction. High voltage direct current (HVDC) power systems use DC for transmission of majority power over long distances. HVDC lines are fewer costly, and fatalities are less related to AC transmission for long-distance power transmission. It connects the networks that have diverse rates and features. Description. High voltage is working for electrical power transmission to scale back the energy lost within the resistance of the wires. Doubling the voltage would bring an equal power at only half the present for a given quantity of power transmitted. Meanwhile, the facility lost as heat within the wires is directly proportional to the square of the present. Doubling the voltage decreases the load losses by an element of 4. Even though power lost in transmission also may be reduced by increasing the conductor size, larger conductors are heavier and costlier. High voltage may not willingly be used for lighting or motors. Therefore, transmission level voltages must be reduced for end-use equipment. Transformers are wont to change the voltage levels in AC transmission circuits. Transformers prepared voltage changes practical. The AC generators are well organized than those using DC. This looks that HVDC lines are more capable than AC lines by seeing all the advantages of DC. Then, the initial cost of the HVDC substation is very high. Their substation apparatus is quite complicated. Therefore, for long-distance transmission, it is better than power is generated in AC. But, it is changed into DC and then again converted back into AC for final use for transmission. This system is economical and also recovers the effectiveness of the system. How does the HVDC transmission system work? By using a rectifier, the AC power may be converted into DC in generating substation. At both the ends of a line in the HVDC substation or converter substation rectifiers and inverters are placed. The rectifier terminal changes the AC to DC, whereas the inverter terminal converts DC to AC. The DC is flowing with the overhead lines, and at the user end again DC is converted into AC by using inverters, which are located in the converter substation. The power rests the same at the sending and receiving ends of the line. DC is transmitted over long distances because it drops the losses and develops competence. Point-to-point system. One system which has other than 2 converter stations and 1 transmission line is called a point-to-point system. It also is said a 2-terminal DC system. Likewise, if a substation has extra than 2 converter stations and connects DC terminal lines, it is called a multi-terminal DC substation. Types of HVDC transmission systems. The HVDC transmission systems are mainly classified into the following types on the basis of arrangement of the pole, line, and earth return. They are monopolar HVDC system and HVDC system having only one pole and earth return. Bipolar HVDC system and HVDC system with 2 poles of opposite polarity. Homopolar HVDC system, it has 2 poles of the same polarity and earth return. Back-to-back HVDC coupling system, it has no DC transmission line. The rectification and inversion are taken place at the same substation by a back-to-back converter. Multi-terminal HVDC systems, it has 3 or more terminal substations. Benefits of HVDC transmission system. Nowadays HVDC systems are preferred over HVAC systems because of the following advantages. The HVDC transmission requires narrow towers, whereas AC systems require lattice-shaped towers. This makes the construction simple and reduces cost. The ground can be used as the return conductor. No charging current, since DC operates at unity power factor. Due to less corona and radio interference, it results in an economic choice of the conductor. Since there is no skin effect in DC transmission, the power losses are reduced considerably. Larger bulk power can be transmitted over long distances. Synchronous operation is not required. Low short-circuit current on DC line. Tie line power can be easily controlled. Power transmission can be also possible between unsynchronized AC distribution systems, interconnection of AC systems of different frequencies. Cables can be worked at a high voltage gradient, which makes them more suitable for undersea cables. Power flow through the HVDC line can be quickly controlled. Industry 4.0, world's longest power transmission line. The 2,500 km transmission line in Brazil is an 800 kV HVDC line that transmits electricity from the Belo Monte hydroelectric dam power plant to Rio de Janeiro, Brazil. The overhead transmission line, which has transmission towers height of 105 meters and taller, crosses 80 cities along its route from the Amazon forest to Brazil's southeast coast. It came into operation in September 2017. The line has two power booster stations at a gap of 1,000 kilometers each and is capable of transmitting 4,000 megawatts of electrical power. Line losses are under 1%. If this was done on AC power mode, line losses could be 25% in this distance of 2,500 kilometers.